Hey there, Science 20. Well, we're back. Hope you still have your calculator handy because now we're going to take a look at how to do calculations for in parts per million. Okay, so this is when we have a solution that is very, very dilute, meaning if you were to find concentration in other ways, you would find really, really small numbers. Well, this is going to be a little bit of a way to kind of uh, give us a good indication as to how dilute something is without, you know, having to write out all these very uh, small numbers or using scientific notation. So a 1 part per million solution means that out of 1 million parts of solution, so if we were to randomly go into a solution and take out a million random particles in that solution, one of those is going to be the solute. All the rest, the other 999,999 particles, are going to be parts of the solvent. So what we do is we take the parts per million. Again, this is also found on page 10, but we take, to find the parts per million, we take the mass of the solute and divide it by the mass of the solution. Now, why are we using masses? Well, we need to remember that since water is going to be pretty much the only solvent we use, we need to remember that 1 liter or 1,000, or sorry, one milliliter of water has a mass of 1 gram. 1 liter, which is 1,000 milliliters, has a mass of 1 kilogram or 1,000 grams. So then what we do, we need to take the mass of the solute divided by the mass of the solution and multiply it by 1 million. Now we can also write 1 million. I'll just put it above here for us. But 1 million is also 1 times 10 to the power of 6. Now, just so you know, you may also come across something where they talk about parts per billion. So if they're doing parts per billion, it would be times 1 billion, or we would just break it down to 1 times 10 to the power of 9. Okay, so as an example, we have a 200 grams sample from a bottle, and it contains 5.4 times 10 to the minus 3 grams of mercury. So just like we did in the percent volume, step one is we want to identify what our solutions are, or what our variables are. Okay, we're identifying the ones that are given. We're given the mass of the solute, 5.4 times 10 to the minus 3 grams, the mass of the solution, which is 200 grams, and we're looking for the concentration in parts per million. Once you've identified that, you go to page 10 in your data booklet, find the right formula that we have. So this is our second step up here. Third step is putting in the values. So the mass of the solute goes up to the top and the mass of the solution goes to the bottom. We're then going to do our division, multiply it by 1 million, and you get 27 parts per million. Now you might be saying, well, okay, sig digs, are we good with that? Yep, because we have 2 sig digs in our mass of the solute and 3 sig digs in our mass of the solution. So our final sig digs need to equal 2. Okay, now when do we use this stuff? Why would we want to use this? Well, there's some chemicals that even in a very small concentration are going to be problematic for us. So if you go to page 42, and you'll see what the allowable toxic level in drinking water is for various chemicals. For hydrogen, it is toxic when it has a concentration greater than 0.001 parts per million. And so, yeah, you can have like a really, you kind of have a 0.00 when it comes to parts per million. That's not a problem. This you could also convert this into parts per billion. That would be 1 part per billion. So 0.001 parts per million is really dilute. Our concentration is 27 parts per million, far greater than what is deemed as being safe for us. So that concentration of mercury in water, even though they're like, well, there's only 27 particles out of a million that are toxic to us. Yes, but it's still toxic to you. You would need far more diluted solution when it comes to mercury to be safe. So, anyways, let's do this example together, and then I'll just kind of walk you through it one more time. I'll show you writing out. I've got part one here done for you where I've identified the variables. But here you're given the part per million of 200 parts per million. The mass of the solution is 9.6 grams. We're looking for the mass of solute that will give us this concentration. Now, this is dealing with carbon monoxide reaching your lungs. So if you have a sample of air, approximately one breath, that's 9.6 grams. And we have 200 parts per million for carbon monoxide. What is going to be the mass of the carbon monoxide? So we've identified our variables. We're then going to take the concentration in parts per million is going to equal the mass of the solute divided by the mass of the solution. Now, unlike before, where you're given the top and the bottom numbers, this is the one we're trying to find. Now, you can put the numbers in first and then rearrange the formula, or you could rearrange the formula and then add the numbers. I'm going to do it the second way. So to find the mass of the solute, I need to isolate it, which means I got to get rid of the mass of solution. Now, mass of solute is divided by mass of solution on this side of the equation. So we're going to multiply both sides by the mass of the solution. Now, since we're not actually doing numbers or calculations, we don't actually have to figure this out precisely. But what we do on one side of the equation, we have to do on the other side. I'm just going to do this as my abbreviation for solution instead of writing out the whole word. So that means this cancels out this. And what we're left with is the mass of the solution multiplied by the concentration in parts per million. So now we'll take our 9.6 grams, which is our mass of solution. We're going to multiply it by 200 parts per million. Oh, I forgot one important thing back here. Times 1.0 times 10 to the 6, because we forgot that multiplied by the parts per million. My bad on that one. Let's also isolate for this. So we're multiplying the mass of the solute by 1 million. We want to divide everything by 1 million, which will then cancel these out. And that means we're going to have this 9.6 times 200 divided by 1 million. Now, the 1 million is an absolute value. You don't need to consider it when determining how many sig digs you have, but I find it doesn't hurt to put it in whatever sig digs our final answers are going to be in. That's not much of a problem. So on my calculator, I'm taking 9.6, multiplying it by 200 parts per million. Now, just so you know, if you're showing your work, I am quite okay with you doing your work step by step. So we multiply everything that's on the top first, and then we're going to divide by what's on the bottom. And so divided by 1 million. And I get 0.00192 grams. Now we're gonna we're we're gonna convert that into scientific notation. So that's going over once, twice, three times. And since I'm moving to the right, it's 1.9, because again, we got two sig digs here, three here. So it's going to be 1.9 times 10 to the minus 3 grams. Okay, so there's some extra practice that you can be doing. So go through that, make sure you understand it well. And in our next video, we're going to talk about doing molar concentration. So I look forward to seeing you there.